So, what are factors and multiples? Let's start off by talking about factors. How do we list the factors of 6? 1 is a factor of 6. How do I know that? Because if I divide 6 by 1, I'm going to get a remainder of 0. 2 is a factor of 6. How do I know that? Because if I divide 6 by 2, I get a remainder of 0. How do I know that part? Well, 2 into 6 is 3. 3 times 2 is 6, and there is no remainder. I follow this process and I get 1, 2, 3, and 6. Each of these numbers can be divided into 6 and you will get no remainder. Let's try another one. Let's try 15. 1. You're going to notice that 1 is a factor of all these numbers. Can 2 go into 15 without a remainder? Well, let's find out. 2 into 15, 7. 7 times 2 is 14, and there's a remainder of 1. This is not 0. Therefore, 2 is not a factor. But 3 is, because 3 into 15 is 5, which means 5 is, and so is 15. So you see this right here? What we just discovered here is that if you had the question that looked like this, is 6 a factor of 32, for argument's sake? Then we come here, we do 32, we go 6. 6 into 32 is 5. 5 times 6 is 30, and there's a remainder that is not 0. Therefore, the answer to this question is no. No. So, what about multiples? So, multiples are a little different, but very easy as well. What are the multiples of 4? All I'm going to do is count 4, 8, 12, and so forth. Now, there are lots of numbers. This goes up to infinity as long as we're counting by 4. Let's put it a different way. Every multiple of 4 can be divided by 4, and we will get a remainder of 0. So we say it is divisible by 4. So what if I had this question that is 244 a multiple of 4? Okay, well, this is how we do this. We come in here, we're going to do our division, 244. 4 into 24, 4 into 0 can't go, 4 into 24 is 6, so this is 24. Then we bring down the 4. 4 into 4 is 1. 1 times 4 is 4. And look, there's no remainder. Therefore, 244 is divisible by 4, which means there's no remainder. This also then means that, yeah, 244 is a multiple of 4. Okay? So, let's go back to factors for a minute. Let's look at the number 3. What are the factors of 3? Well, there's 1, and then there's 3. These two numbers can go into 3 without a remainder. 2 is not on this list because 2 into 3 gives a remainder of 1. Let's look at another number. Let's look at 9. Factors of 9 are 1, 3, and 9. Let's look at 11. The factors of 11 are 1 and 11. Now, these two numbers have something in particular in common. They have 2 factors only. 2 factors only. And in fact, those factors are very particular and very specific. Those factors are 1 and itself. Itself meaning the number itself. So you will notice here is 1 and 3. See? 1 and the number itself. It's here is 1 and 11, the number itself. Those are called prime numbers. Prime numbers are numbers which have two factors only, 1 and itself. 1 and itself. All right. So let's talk about common factors. So now we're going to take into account multiple numbers. So if I have 6 and 15, what are the common factors? Well, 6 has 1, 2, 3, and 6. 15 has 1, 3, 5, and 15. So those are the factors of the individual, but the common factors are the ones that exist for both of them, 1 and 3. So the common factors then are 1 and 3. If you were asked to find the common factors, right? Now, similarly, you might be asked to find the common multiples. So again, let's look at the same example there. So 6 and 15. So you have 6, 12, 18, etc., etc., etc. And you have 15, 30, 45, etc., etc. And now, of course, you would just go in and see where you find the common numbers in here. So that will be the common multiple. Now, we don't ask you to find common factors. We don't ask you to find common multiples in math. We are very specific with what we want. So, for example, we might ask you to find the highest common factor. So, let's go back. 6 was 1, 2, 3, and 6. And 15 is 1, 3, 5, and 15. And so what's in common to both of them are 1 and 3. So these are the common factors. But the HCF, highest common factor. So these are the common factors. So I'm not looking at all of these in it. I looked at these to find out what they have in common, and now I'm going to look at what they have in common and find the highest one, which is this. And so the HCF of 6 and 15 is 3. And I'm going to get multiple numbers for this. Highest common factor. Okay? So that's how we find that. All right? Similarly then, let's find the highest common, the lowest common multiple. Okay? Let's find the lowest common multiple. So again, let's come here. Let's go to 6. And the multiples of 6 are 6, 12, 18. And we could go on and on and on. So we have to know at what point we're going to stop, right? So let's see what 15 looks like. 15 is 15, 30, 45. So far, there's nothing that these things have in common. So I've got to continue up here because this is already at 4 to 5. So let's try to get closer to 4 to 5 here and see if we find something that they have in common. So now 6, 12, 18, 24, 30, 36. Oh, but look, 30 is here and 30 is here. So I could keep going on and on and on, and I'm going to find more numbers that they have in common, but I'm looking for the lowest or the least. I've already found that. That's 30. So the LCM of 6 and 15 is equal to 30. Okay? So this is how we go ahead and do that, how we find the least common multiple. Now with practice, we're going to be able to do this in our head. Okay? You're going to be able to do this in your head with practice. But this is the process, the conceptual understanding of finding the LCM and the HCF. Other videos in this and other series are available. Like, share, and subscribe if you found the video helpful. If there's a topic you'd like to see us tackle, just let us know.